In this video, I'll be covering Lesson 1.1, 1.2, Guided Notes, which talks about interpreting and solving algebraic expressions. So before we get into the lesson, I have a question here that I'd like you to think about and solve on your own. You can jot your thoughts down on a piece of paper, just do it in your head, but I want you to look at this problem and try and solve it. And this is a problem, I actually found it on Facebook, and it's created a lot of controversy, so I want you to try and figure out what the answer is. The most common two solutions to this problem that I saw were 9 and 1, and it kind of got into a heated debate on Facebook of what the correct answer really is. And so it raises the question, how can we have one problem and have people arguing between two answers? And maybe you even got a different answer. This is an algebraic expression that we're trying to solve. An algebraic expression is a mathematical phrase. It's almost like a math sentence, and it's made up of numbers. We see those here, right? We see the numbers 6, 2, 1, and then there's another 2. Sometimes algebraic expressions include variables. Variables are letters. So you could see X, sometimes we use Y, sometimes we use A. You could use any letter to stand in for an unknown number in an algebraic expression. And then finally we have operations, and the most basic operations are addition, subtraction, and then we have multiplication and division. So this algebraic expression we see up here, it includes numbers and operations, and the reason that we get two different answers is because people are maybe solving or using the operations in different order. And so it's important that we have an order of operations when we are solving algebraic expressions. Otherwise, this would be a problem in math. We would, if we solved things in whatever order we wanted, we would always end up with different solutions. So that's the purpose of having an order of operations. So what we do is we use PEMDAS. This is probably something you're familiar with. So P stands for parentheses. Parentheses are these little kind of brackets that go around a group of numbers and operations. So what we're going to do is evaluate expressions inside grouping symbols. And it's important to note that we're going to work from the inside out if there's multiple parentheses, because we could have these parentheses, then sometimes there are brackets, and then sometimes we even see these squiggle brackets that show there's multiple groupings going on. So what we would do is we would work from the inside out, do the inside operations first and then work outside. After we have worked within the parentheses, we're going to solve any exponents. So exponents are where we have these little like squared, or maybe we could have a cubed, or maybe we could even have to the 4th power. So we're going to evaluate all powers, and when we're evaluating powers, it means that you take, for example, if this was p squared, it means we're going to do p times p. You're multiplying it by itself. If we have e to the 3rd, we're going to do e times e times e. We're multiplying e by itself 3 times. If we had s to the 4th, that means we have s times s times s times s. So this is how we evaluate powers. After parentheses and exponents, the next thing that we do is multiplication and division. This, I think, is where our problem breaks down up here in our example. Multiplication does not come before division necessarily. Multiplication and division are on the same level, but we do it from left to right. We work from left to right. So we're going to do all multiplication and or division from left to right. So it's not M and then D, but it's M and D together from left to right. So that's going to be important to note. And then addition and subtraction work the same way. Addition and subtraction are on the same level. We don't do addition first and then subtraction. We do them both in the same step, working from left to right. Let's practice a few more examples together. So looking at this first one, I have, and I'm going to practice reading this, 4 times 8 to the 3rd power. Or we could say 8 cubed to the 3rd power that has a special name called cubed. So 4 times 8 cubed. Once again, I'm going to refer back to PEMDAS. There are no parentheses. but there are exponents, so that's where I'm going to start. I'm going to start right here with 8 to the third power. Well, remember, to the third power means that we're going to multiply 8 by itself 3 times. 8 times 8 times 8. So that's the first thing that I'm going to do, and you can feel free to use a calculator to help you out with this. I actually recommend having a calculator on hand. If you know how to type in 8 to the third power, that's fine, or you can type in 8 times 8 times 8. And you should get 512. Then we drop everything else down. That means I have multiply and then a 4. So my next step is multiply and divide. Well, I only have one thing left to do, and that's to multiply 4 times 512. So use your calculator, and you should get 2,048. All right. This next one, I'm going to read it first. The quantity, because it's in parentheses, the quantity 3 plus 5 times 5 plus 1. So the first thing I'm going to do is work inside the parentheses. So the first thing is 3 plus 5, which is 8. Everything else is going to drop down. I already solved everything in the parentheses, so now I have times 5 plus 1. The next step is exponents. I don't have any, so I'm going to move on to multiplication and division. I have multiplication here with 8 times 5. 8 times 5 is 40, and then I'm going to do plus 1. That's my last step. 40 plus 1 is 41, which is the final answer. This one is a bit more complicated. I'm going to practice reading it first. I have 3 times the quantity, because there are parentheses or brackets, 3 times the quantity of 2 plus the quantity 12 divided by 3, quantity squared. So this one is a little weird with all those parentheses. There's a lot of quantities going on, but basically there's multiplication, we're going to be using everything here. So we need to be very, very careful with order of operations. So first thing is parentheses. And remember this note, I said we're going to work from the inside out. That's important here because we have 2 types of parentheses. So if I go to the inside, I'm going to go here, and this is my starting point. So I'm going to start with 12 divided by 3, which is 4. Everything else is going to drop down. So the first thing I'm going to drop down is the squared, and then I'll drop this bracket down. Then there's a plus, 2, another bracket, and a 3 on the outside. So I just simplified this quite a bit. So now I'm going to see what I should do next. Well, we still have parentheses, so I want to look inside those parentheses, but inside the parentheses we have addition and we also have an exponent. The first thing we're going to do is the exponent. So I'm going to do 4 squared. What 4 squared means is 4 times 4. 4 times 4 is 16 plus 2. Keep the brackets or parentheses because I haven't solved everything in there yet, and the 3 drops down. So I'm going back to number 1, parentheses. I'm still not finished. I need to do this addition before I move on. 2 plus 16 is 18. And then that is times 3. Multiplication is implied here because there's no symbol. It's just a number with a parentheses. That means multiplication. So finally, we can do this multiplication. 3 times 18, and that gives me 54. In this last one, we have a fraction, and I know fractions can be freaky when we first look at them, but a fraction is just division. So if we can think of this as just whatever's on top divided by whatever's on bottom, then it can help simplify this for us. Now, something I want to note is that when we have a fraction, it is implied that the numerator and the denominator are their own thing. So when we're solving a fraction, we're going to do everything on top, we're going to do everything on bottom, And then the last thing we're going to do is divide or simplify the fraction. So we're going to just treat the top and the bottom as separate things. So first I'm going to look only at the top. So I have 3 plus 2 to the third power. So I have addition and I have exponents. I'm going to do the exponents first. 2 to the third power means I have 2 times 2 times 2, which is 8. So I carry over the 3 plus, and this is 8. Then I'm going to forget about the top and I'm going to look at the bottom. On the bottom I have 4 squared times 3. So I have an exponent and I have multiplication. Exponents come first. 4 squared means I have 4 times 4. 4 times 4 is 16 times 3. Next, I'm looking back at the top again. 3 plus 8, that's my final step. So I'm going to add together, and I get 12 on top. On bottom, I have 16 times 3, which is 48. Now, here we have 12 over 48. I have a small number on top divided by a big number. If you think about how fractions work, if I plug this in my calculator, 12 divided by 48, you're going to get a decimal or a fraction. So rather than putting our answer in decimal form, we're just going to simplify this fraction, meaning I'm going to ask myself, what number can I divide both the top and the bottom by? We're just going to simplify it. Well, I know that 48 is actually divisible by 12, so I can divide both the top and the bottom by the number 12 to simplify this fraction. 12 divided by 12 is 1, and 48 divided by 12 is 4. So my final answer here is the fraction 1/4. Moving on, we're going to add another layer to this order of operations. In some cases, we're going to use the substitution property. If we go back up to what an algebraic expression is, so far we've only looked at algebraic expressions that include numbers and operations. But sometimes an algebraic expression will include variables, which are letters. If we have an algebraic expression that includes variables, sometimes it'll give us kind of a key or a code and tell us what those letters mean. And so we can use that, we can substitute those values for the variables. So I think the best way to figure this out is just by taking a look at it. So here we have x to the third plus 5 times the quantity y minus 3. And it's telling us if x equals 2 and y equals 12. Obviously, if I just look at this, there's nothing really I can do because x to the third, that wouldn't give me a number. It would just be x times x times x, and that isn't making it simpler, it's making it more complex. So, but they gave me kind of an answer key. They're telling me that x equals 2. So if x equals 2, wherever I see an x, I can put a 2 instead. So I have 2, and then to the third, plus 5 times, and they're telling me that y equals 12. So anytime I see a y, I'm going to put a 12. So 12 minus 3. Now that I have only numbers and operations, I can continue using order of operations to solve. So I'm going to start with my parentheses first. 12 minus 3 is 9. I'm going to keep the parentheses and the 5 and the 2 to the third. Next, I have exponents. So I'm going to do 2 to the third, which is 2 times 2 times 2, which is 8, plus 5 times 9. Next, I have multiplication, 5 times 9. 5 times 9 is 45. And finally, I have 8 plus 45, which is 53. Now we're going to take a look at our final example. A squared plus 2b. And when we have 2b, it's implied that it's 2 times b. So we're going to use substitution once again. It's telling us here that a equals 6. So anytime I see an a, I'm going to put a 6 in its place. So I have 6 squared plus 2, and it's telling me that b equals 3. You need to be careful when you plug in the b, because if I just put it here, it looks like 23. But this is 2 times b. So you need to put a multiplication symbol in there. You could use parentheses or you could use a dot. We want to get away from using the x for multiplication because we will use the variable x. So I'm going to do a dot, 2 times 3. Now that I only have numbers and operations, I can use PEMDAS to solve. So there's no parentheses, but I do have an exponent. I have 6 squared. 6 times 6 is 36, plus 2 times 3. Next, I'm going to do multiplication and division. So I'm going to multiply 2 times 3, which is 6. And finally, I'm going to add 36 plus 6, which is 42.